a lot of the things that I talked about yesterday with Alec are still very relevant here. And right now, all we're really doing is kind of focusing on more methods and also talking a little bit about this idea of nested arrays. But fundamentally, we're kind of really just building upon what we talked about yesterday already. So on we go. So yesterday we talked about a bunch of kind of simpler, more straightforward methods around how to modify arrays and how to get arrays, how to reverse arrays, how to get data from arrays. Today we're just going to do a little bit more complex methods. So the first one we'll talk about is the splice method. And with all of these methods, make sure you understand what they do, but don't necessarily feel like you need to memorize or remember exactly what each argument does. In the real world, if you had to use any of these arguments, it's totally fair game for you to look up, what the second argument or the third argument is. Like for splice, actually, for me personally, like a lot of times when I use it, I still look up the documentation just to make sure in my mind, I know what it does, which is it basically is something that we can use to add or remove elements from anywhere in the array. But sometimes I still look up the documentation just to make sure like the third argument or the second argument do what I think they do. So anyway, all splice does is allows us to add or remove elements from the middle of the array. And the arguments that it takes are, the first argument is an index, so basically where do we start? The second argument is a number that tells us how many elements to remove from that index, inclusive of that element. And then lastly, what it does is, or rather, then what it will return then is a new array with all the removed elements. So here, if I have an array called names and it has 3 items in it, George, John, and Thomas. If I create something called single term precedence and I capture the return value out of names.splice 1, 1, well, what that does is the first argument tells us we're starting at index 1, which is John. The second argument tells us that we want to take away one element starting at John, which is John. And so now, once I do all of this, when I console log out names and when I console log out precedence, single term precedence, you'll see that the names array was fundamentally changed, right? So now we have taken away John. So now all that's left is George and Thomas. And the returned value, or the value that the splice function gave back to us, was an array, was all of the elements that were removed. And in this case, the only element that was removed was John. And so yesterday we talked about how to add or remove things from the beginning and the end of arrays. Now you can kind of see how we can remove things from anywhere in the array. And we'll also talk about adding things in just one more slide. So here, yep, same idea. If I wanted to do now, say if I want to go to index 1, which is George, and I want to remove 2 elements, well, I do the same thing as before. And now when I look at my original array, my names array on line 5 there, you'll notice how we've taken away George and John from the array, right? Because we initially had a names array with 4 names in it. Then we spliced from index 1, we took away 2 elements. So now all that's left is Paul and Ringo. And then the return value is names.splice 1, 2. And so what's returned then is the array of all the elements that were removed, which is just George and John. And then lastly, what splice also allows us to do is able to add new elements at a given index. And so here I have George, Paul, Pete, and John. And now I still call my splice function, and my first 2 arguments are still, they're still relevant to what we talked about before. But now my third element is going to be a string Ringo. And so what the third argument allows you to do in the splice function is the first function picks the index, the second function removes a number of elements, and then the third argument and onwards actually allows you to be able to add elements at that position. And so here when we start at index 2, which is Pete 0, 1, 2, so the third element, which is Pete, we now remove one element because that's the second argument, so we remove Pete. But now where Pete used to be, we're going to insert Ringo. And so now when I look at names, it's now Paul, George, Ringo, and John. And when I look at the value that was returned from the splice function, it is an array with only one element, which was the element that was removed, which is Pete. Okay. And so one of the really interesting about the splice function is, even though it takes in at least two arguments by default, because it allows you to add as many things as you want. One of the really interesting things is, if you notice here, is that we can actually add as many elements as we want, and we just add each new element as a subsequent argument. So here I want to go to the second position, or sorry, index 2, which is a third position. So Paul, George, Ringo. Notice how my second argument is 0, which means I don't want to delete anything. And then I want to insert Pete and Stuart into the array. And so now when I look at my original array now, the array has 6 items, right? So after after George, we then inserted Pete and Stuart. But then more importantly, in the removed elements, what did I remove? Well, I removed nothing. But still, I still need to return an array containing everything that I removed. And so therefore, the function just returns an empty array. And so this is something to just kind of be aware of, is that whenever you do this, the dot splice will always return an array. And if you don't delete anything, then it'll just return an empty array. Any questions on dot splice? Cool. The next method we'll talk about is the join method. The join method works very much like the concatenate method that we've seen before for strings, where we just kind of add 2 strings together. You can't really just add 2 arrays together, but essentially what that join does is it helps us mimic that functionality. So here, if I have an array called names, which is 4 items, and then I say names.join. Oh, sorry. I totally misspoke here. What the join method does, it concatenates the elements of the array, not the array itself. I'm sorry. And so what that means is that if I, in this case, if I have an array of strings, if I do dot join, what it will do is it'll actually take every element in the array and just join them together into one long string. Notice how on line 6 there, whatever dot join returns, we capture in a new variable, in this case called join string. And so what that means is that the original array names is not changed. So here, when I do names.join and I console log out what the return value is, you'll see that I've returned back a new string that's Paul, George, John, and Ringo. It's one string separated by a comma, and I do a type of to make sure that it is indeed a string. Sorry. By default, when you use .join, what it'll do is it will join every element in the array with a comma. But if you want to join it by something else, like for example the word and, all you have to do is pass it in as the argument into the join function. And so now if I do Paul, George, John, and Ringo, and I do as an array, and I do .join and I looked at the join string, then it will be as Paul and George and John and Ringo. And so what the join method does is it gives us a kind of an easy way for us to combine all the string elements of an array together. This is what I got confused with. This is a .concat method, and this is the one that actually allows us to be able to join 2 or more arrays into one array. And what it does is it joins it by returning a brand new array, so it doesn't change the original array. So here, if I have an array called older, and then I have an array called younger, and this has 2 items each. If I do older.concat younger, that will not change older and will not change younger. What it will do is it will return a brand new array with all 4 elements in the arrays joined together. Sorry, I'm gonna get a Kleenex really quick. I'm battling a little cold right now. 1 second. Sorry, folks. So what the concat method allows us to be to now actually combine arrays in a way that we weren't able to do it before. And one of the biggest traps I see people when they use this is they forget that .concat returns back a brand new array. And so always make sure that whenever you use .concat that you're actually capturing the value that's actually being returned. The last thing we'll talk about today is this idea of nested arrays, right? And hopefully you've already kind of have seen some variation of nested arrays before. We know by now that arrays can contain any type of values, and when we say any type, it also includes other arrays. And so it's very possible for us to have something that looks kind of like this array here. In the related things array, don't get confused, right? The related things array only has 2 items in it. The first item is an array that in of itself has 2 items, and the second item is another array that has 2 items in it. But once again, just to make sure we're really clear, when we look at the related things array, just note that there's only 2 items in this array. Okay, and each of those items is an array that contains its own number of items. If I want to take a look at the first element in the related things array, I will use a bracket notation that we've seen before for both arrays and strings. And if I want to look at the first element of the second element in the related things array, which basically means if we work our way from left to right, we look at related things, then we look at index 1, so we look at a second element, and then we say let's look at the first element of that second element. Then what we see is we actually are able to kind of traverse or go into that inner array. So for the first printout, related things index 0, that's the first element in related things, we get back an array with 2 elements. For the second line, on line 6 there, we look at related things with index 1, so the second element, and we look at the first element in that second element. So now we're looking at New York, because that's the first element of the second element of the related things array. And then last but not least, when we look at related things and see how many items there are in the array, we only see 2 items. And once again, this comes back to the idea that even though nested arrays can contain multiple arrays, those arrays collectively count as one thing, right? If I have an array with 4 things in it, that's still one array, or that's still one item. And so one of the things that we'll be looking at today for one of your workshop problems is, well, now how do I actually go through and traverse, or rather go through not just an array with one layer, but rather nested arrays too. So in this case, I have an array called RSVP groups that has multiple things. It has both strings as well as arrays of other strings. So assuming this is, for example, the guest list for a party, the question becomes, how do I actually go through now and print out, or rather access each individual string in the array? And so if we do what we did before, if we're just looking at one item at a time, we really quickly realize that it's not sufficient, right? Because if I look at the first element in RSVP groups, it's an array. So I actually need to now go inside that array to figure out what is inside of it. And so that means that when we have a for loop, we actually also need more than one layers of a for loop as well. So here, if I look at the code as we have it written right now, on line 3, I set up my traditional for loop that iterates over, or that loops over, the RSVP groups variable. On line 4, we create a variable called element that we use to just temporarily capture the element there. On line 5, we actually check the element to see if it is an array, because we see the array.isArray function here. And then on line 6, what we actually write is, if the element is an array, well, now let's write another for loop, and let's go through that inner array too. And when we have an inner array, we console log out the name. And if the element is not an array, so okay, if we look at line 11, we fall into our else statement. Then all we do is we print out the element, because we assume that if the element is not an array, then it's a string. And so this slide will be very useful to you in your workshop today as kind of a guideline for how we think about handling data structures that have multiple nesting types, right? So if I have things inside of other things, how do I deal with it? Any questions on the code here, or really anything we've talked about so far? Sorry, was that a question? Okay. Well, if not, then that's pretty much it in terms of like the new material we'll be covering today. One last thing we'll talk about very briefly is just that when we have nested arrays, they actually become one of the things that you'll see is that we can also use it to represent grids, which is a little bit of a novel way of using nested arrays in almost a graphical way. And so what I mean by that is, if I want to create a 3x3 grid in JavaScript, there's no data structure that lets us do it kind of out of box very easily. But if we think about the way that a nested array is set up now, if I do something like that, like this here on line 7 through 11, we now are able to create an array that holds inner arrays. And if each of those arrays holds 3 things, and we have 3 of those, then what we've done is we've effectively are able to create a 3x3 grid. Now, if you print out the grid variable in JavaScript, it's not going to print out in this exact layout, and that's fine. Like that's to be expected. But the way that we think about the data in there is actually can be very similar to a grid format. And so all we're saying here is, well, here if I want to actually get, like, for example, the first column of this grid, if we look at line 13, there's a lot of traversing there, but really quickly, if I just kind of zoom out and think about it, all we're really saying is the first column of this grid is equal to the first element of the first element in the grid, as well as the first element of the second element in this grid, as well as the first element of the third element in this grid, which in this case, if we look at line 7 through 11, the first element of each item is just a 1, right? And so it's in effect on line 13 there, all we're doing is capturing 3 1 values, and we're putting all that in an array, and so now we have an array with 3 1s. And so it's a little bit of like a mind trip to think about in terms of how we want to spatially think about it if it was a visual. But if we think about, like, the fact that nested arrays are effectively just kind of 2D data structures, we're able to actually present any type that we want of 2D data structures. And so first column is an array with 3 items. If I console log it out, I see my array was just 1, 1, and 1. Notice how when I grab each item, I'm just grabbing a number. And so on line 13 there, actually, it's kind of very subtle, but notice how we're also putting the 1, 1, and 1. We're putting all of that in an array in of itself. Cool. And so that's it for today. If you guys have any questions, feel free to ping me in terms of asking for help or messaging me on Slack. I know there are a few questions last time, but if you and your partner end up finishing early, feel free to head out. We don't have any more problems or work for you. If you do want to stay for the review, we'll probably start that around like 9:20, 9:25 is, depending on how different groups do. So are there any questions before we get started? Oh, sorry, was there a question here? I'm sorry. Are there methods to know for job interviews, questions, or everyday work? Yes and no. Like, usually, like for something like dot reverse or dot slice, people will expect you to kind of know at a high level what they do and probably how to use it very quickly. But if you're using, a function, you say, hey, I know slice does this, or I know splice does this, but I'm just I forgot what the first argument versus the second argument is. I don't think people will hold it really against you as long as you demonstrate it. It's almost like you're dealing with someone who clearly knows what it is, and they just, like, it's like you're dealing with a chemist, right? And they forgot what, like, the number 27th element is, right? It doesn't reflect on their skills as a chemist necessarily, right? It's like a piece of data that maybe people forgot about. So you should definitely know what all of these functions do, but don't get too hung up on memorizing each and every argument. From Ernesto's question, it seems like it removes elements to the right of the index. Can make it remove elements to the left of the index? The quick answer, as far as I'm aware, is no. It basically will go to an index and start removing it going rightwards. If you need to remove going leftwards, then you can probably rejigger it. So if you know how many elements you're going to remove, that stays the same. But then you probably just want to start at the index minus how many elements you want to remove if you want to quote unquote mimic the effect of deleting left. And then Carl says it removes the index different from slice. Yes. Whereas slice, I think, stops. The first argument is inclusive, but it stops before it gets to the second one. Splice actually acts upon the index in which you're feeding it as a first argument.